Most people don't realize this yet, but car companies have quietly started building vehicles that are designed to be thrown away instead of repaired. And once you see how it works, it's honestly hard to unsee. This same replace it instead of fix it mindset has existed for years in other industries, and now it has fully made its way into the automotive world, where a single major failure can instantly turn a perfectly drivable vehicle into a financial total loss. In this video, I'm breaking down 8 cars where one breakdown is often enough to end the vehicle's life, not because it's old or abused, but because repairing it simply doesn't make financial sense anymore. And that's why we're starting at number 8 with a car most people would never expect. An affordable SUV that looked harmless on paper, but turned out to be one of the clearest examples of this disposable design. The Ford EcoSport. Specifically models equipped with the 1.0-liter EQ Boost 3-cylinder engine. On paper, this engine was celebrated as an engineering breakthrough, winning awards for innovation, fuel efficiency, and compact design. But behind the praise is a design decision so flawed that it has led to thousands of catastrophic engine failures. The core issue is something Ford calls a wet timing belt. Traditionally, timing belts run dry outside the engine, while timing chains sit inside the engine made of metal and lubricated by oil. Ford combined the worst aspects of both designs by using a rubber timing belt that runs inside the engine, fully submerged in hot motor oil. That's where everything starts to go wrong. Rubber was never meant to live in oil long term. Over time, the belt degrades, softens, and sheds tiny rubber particles directly into the oil system. Those particles circulate throughout the engine, slowly clogging the oil pump pickup and contaminating every lubricated component. The most dangerous part is how quietly this happens. There are often no warning lights, no loud noises, and no gradual decline. The engine simply loses oil pressure and fails suddenly, often while driving. Most failures occur between 60,000 and 100,000 miles, right when many owners believe the car should still be dependable. Once the oil system is contaminated, there is no economical repair. Flushing doesn't solve the problem, and replacing the belt alone doesn't remove the debris already circulating inside the engine. In most cases, the only real fix is a full engine replacement, which frequently costs more than the vehicle itself is worth. At number 7 are the plug-in hybrid versions of 2 American icons, the Jeep Wrangler 4xe and the Jeep Grand Cherokee 4xe. In the rush to meet electrification targets, Jeep's parent company, Stellantis, pushed these complex hybrid systems into production quickly, and early owners are now discovering that they're effectively acting as beta testers. These 4xe models have already been hit with multiple recalls and widespread owner complaints. Drivers report sudden loss of power, vehicles shutting down in traffic, warning messages that force the car into limp mode, and complete hybrid system failures that leave the vehicle immobile. While many of these problems have been addressed under warranty so far, the real concern begins once that coverage ends. The heart of the 4xe system is the high-voltage battery pack, along with its cooling system and supporting electronics, and none of it is cheap. Once out of warranty, estimates for battery replacement alone commonly range from $8,000 to over $15,000. That doesn't include labor, diagnostics, or failures in the surrounding control modules, which can drive costs even higher. On vehicles that are only a few years old, a single repair bill like that can exceed the vehicle's market value, effectively turning it into a total loss. Because the hybrid system is so deeply integrated into the drivetrain and electronics, independent repair options are limited, leaving owners with few alternatives outside of the dealership. At number 6 is another luxury brand that built its reputation on longevity and engineering, Mercedes-Benz. Specifically models equipped with the 48-volt EQ Boost mild hybrid system introduced around 2020. This technology was marketed as a simple, low-stress way to improve fuel economy and smooth out performance. But in reality, it introduced an entirely new failure point that many owners weren't prepared for. The EQ Boost system integrates a 48-volt battery, an integrated starter generator, and a network of control modules directly into the vehicle's core electronics. Unlike traditional drivetrains, these components aren't supplemental, they're essential. When something goes wrong inside this system, the car often doesn't degrade gradually, it simply shuts down. Owners describe situations where the vehicle refuses to start, throws multiple warning messages, or disables itself entirely, even though the engine and transmission are mechanically fine. This is what many refer to as the car being bricked, where software or electronic faults render the vehicle completely unusable. What makes this especially dangerous is the repair landscape. Independent mechanics are effectively locked out. Diagnosing and repairing EQ Boost failures requires Mercedes-specific software, proprietary tools, and factory authorization. That gives dealerships a complete monopoly over repairs, with no lower-cost alternatives once the warranty expires. This is the opposite of what buyers expect from a luxury brand, especially one historically associated with durability. At this point in the list, it should be obvious that complexity is the common thread, and few vehicles represent that problem better than the Volvo XC90 T8 plug-in hybrid. On the surface, it looks like the ideal modern luxury SUV, combining safety, efficiency, and Scandinavian design. Underneath, however, it's one of the most mechanically and electronically overcomplicated vehicles Volvo has ever produced. The T8 combines a turbocharged engine, a supercharger, an electric motor, a high-voltage battery pack, and an all-wheel drive system that relies on electronics instead of mechanical connections. When everything works, it feels impressive. When something fails, diagnosing the problem becomes a nightmare because no single system operates independently. Owners report recurring issues with hybrid control modules, battery cooling failures, electric drive faults, and drivetrain warning messages that can disable the vehicle entirely. In many cases, the car will refuse to move even though the gasoline engine itself is still functional. Like many modern hybrids, the software decides whether the vehicle lives or dies. Out of warranty, the financial risk becomes severe. High-voltage battery replacement estimates regularly land between $10,000 and $15,000, and that's before factoring in labor or failures in the surrounding electronics. Because many of these components are proprietary and tightly integrated, independent repair options are extremely limited, leaving owners locked into dealership pricing. This is a perfect example of a vehicle that wasn't designed with long-term ownership in mind. It's technologically impressive, comfortable, and safe when new, but once it ages out of warranty, it becomes something very different. At number 4 is one of the most recognizable luxury SUVs in the world, the Land Rover Range Rover. For years, it represented status, comfort, and off-road capability, but modern versions have developed a reputation for something far less flattering. This is a vehicle where complexity itself has become the enemy. The problem isn't a single weak component, but the sheer number of systems layered on top of one another. Modern Range Rovers are packed with highly sensitive electronics, advanced driver assistance features, and software-controlled systems that all rely on constant communication to function properly. When one sensor or module starts sending bad data, it can trigger a chain reaction of warnings, faults, and shutdowns across the vehicle. Owners frequently report electrical issues that seem to appear out of nowhere, ranging from infotainment failures and warning lights to vehicles that refuse to start entirely. These problems are often intermittent and difficult to diagnose, which drives repair costs even higher because troubleshooting alone can take hours using dealer-only diagnostic equipment. The air suspension system adds another major point of failure. Over time, air springs dry out and crack, compressors wear out, and height sensors fail, most commonly between 60,000 and 100,000 miles. Repairing even a single corner of the suspension can cost several $1,000s, and full system repairs quickly climb into five-figure territory. What truly pushes these vehicles into disposable territory is how insurance companies handle them. Because repair costs escalate so quickly, insurers are increasingly totaling Range Rovers, even six-figure models, over failures or damage that would be considered routine on simpler vehicles. The combination of extreme complexity, high parts prices, and labor-intensive repairs means it often makes more financial sense to write the vehicle off than to fix it. At number 3 is one of the best-selling family SUVs in the United States, the Nissan Rogue. For many buyers, it was chosen specifically because of its reputation for practicality and efficiency, but for a large number of owners, it became something very different. This is a family vehicle built around a transmission that was never designed for long-term durability. The Rogue relies on a continuously variable transmission supplied by Jatco, and while the idea behind a CVT is smooth acceleration and improved fuel economy, the real-world execution has been deeply problematic. Owners commonly report shuddering during acceleration, loud whining noises, overheating warnings, and sudden loss of power that can leave the vehicle stranded without warning. Most failures occur in a predictable window, typically between 60,000 and 100,000 miles, right when drivers expect the vehicle to settle into reliable middle age. The root cause is a combination of inadequate cooling and internal wear that causes the transmission fluid to degrade, which in turn damages critical components inside the unit. What makes this especially frustrating is that these transmissions are not designed to be properly serviced. Internal filters cannot be replaced without completely disassembling the transmission, and many independent shops refuse to rebuild them at all. As a result, the standard repair is full replacement, not repair, with costs that frequently exceed the vehicle's market value. By now, a pattern should be clear, and the Audi E-Tron is one of the cleanest examples of how modern electric vehicles can cross the line from innovative to financially disposable. When it launched, the E-Tron was praised as Audi's first serious electric SUV, offering luxury, performance, and cutting-edge technology. What most buyers didn't realize is how quickly that technology could turn against them. The E-Tron is built around a massive high-voltage battery pack integrated deep into the vehicle's structure, along with complex cooling systems, power electronics, and proprietary software that controls nearly every function of the car. When everything works, it drives smoothly and quietly. When something goes wrong, the vehicle often doesn't limp along. It shuts down. Owners have reported battery faults, cooling system failures, and electrical issues that trigger reduced power modes or complete shutdowns. In many cases, the vehicle will refuse to drive at all, even though the motors themselves may still be mechanically intact. Like many modern EVs, the software ultimately decides whether the car is allowed to operate. Out of warranty, the financial risk becomes extreme. Battery-related repairs or replacements are commonly quoted in the $10,000 to $20,000 range, and because these components are sealed, proprietary, and tightly integrated, there are virtually no independent repair options. Once the battery or its supporting systems fail, replacement is often the only path forward. At number 1 is what may be the most disposable car ever built: the Tesla Model Y. This isn't a cheap economy car or a niche experiment. It's one of the best-selling vehicles in the world and a symbol of where the automotive industry is headed. The problem isn't the electric motors or even the battery alone, it's how the car is built. Tesla relies on a manufacturing method known as gigacasting, where massive sections of the vehicle's structure are formed from a single piece of aluminum using enormous presses. On the Model Y, large portions of the rear frame are one solid casting. From a manufacturing standpoint, this is incredibly efficient. It reduces parts count, speeds up assembly, and lowers production costs. From a repair standpoint, it's a disaster. On a traditional vehicle, moderate collision damage can often be repaired by replacing individual panels or structural components. With gigacasting, that same damage can crack or distort the entire cast section. There is no approved method to cut, weld, or partially repair it. The only factory-approved solution is full replacement of the entire structural casting, an extremely complex and expensive process. As a result, insurance companies are totaling Model Ys at a rapidly increasing rate, even after accidents that would be considered routine repairs on conventional vehicles. Cars with relatively low mileage and otherwise minimal damage are being written off simply because repairing the structure no longer makes financial sense. That's before factoring in the battery. Out of warranty, high-voltage battery replacement estimates commonly range from $10,000 to $20,000. When combined with structural repair limitations and rapid depreciation, a single major issue can instantly exceed the vehicle's market value. When you step back and look at all of these cars together, a clear pattern emerges. These vehicles didn't fail because owners neglected them or because technology itself is bad. They failed because modern cars are increasingly designed around complexity, cost-cutting, and replacement rather than long-term repairability. Once a single critical component goes down, whether it's an engine, a transmission, a battery, or even part of the vehicle's structure, the repair bill often exceeds the car's value, turning something that still looks perfectly usable into a financial total loss. That doesn't mean all modern cars are bad, but it does mean buyers need to be far more careful about what they choose to own long-term. Understanding which vehicles are built to last and which ones are quietly designed to be replaced can save you tens of thousands of dollars down the road.